going to look at the slope of a line, and the slope of the line describes or represents how steep that line is. In mathematics, we commonly refer to this as rise over the run. So this is the change in the vertical aspect of the line over the change in the horizontal aspect. In science, you might know this slope as being the rate of change. That's what it's commonly known as in science. And in finance, it's commonly known as the rate of increase or the rate of decrease, as it may be. So these are other words for the slope of a line. So let's take a look at an example of what the slope is. In this example here, we have a line that's coming down here. This is our y-axis here and our x-axis here. Now, this from here to here represents the change in the vertical aspect. So this distance here, this is the vertical change. And this is sometimes referred to as delta y. Delta means the change in. Now we can find this value in two ways. We can take a look at the 2 points that are being represented. So from this line here, this is where y equals -1. And this point here, this is where y equals 5. And we can subtract this value for y minus this value for y. So that would be 5 minus -1, or 6. And that would be the change in y from here to here. Now we could also count. So starting here, that's 1, 2, 3, 4, 5, 6 units. We've moved 6 units up. And that's the same value. So the change in y is 6 units, we can say. Now let's take a look at the horizontal change. So from here to here, this is called the horizontal change. And we can refer to that as delta x also. Now we can do the same thing here. This value here for x, this is where x equals -1. And this value here is where x equals 3. So we could also do x2 minus x1, and that would be 3 minus -1, which is equal to 4, and that would give us our change in the horizontal. Now we could also count this starting from this point, 1, 2, 3, 4 units, and that is 4 units there. So this is our change in y and our change in x. So our slope is defined as the rise over the run, or the vertical distance divided by the horizontal distance. So the vertical change divided by the horizontal change. And in this case, that is equal to 6 over 4, and that we would reduce to 3 over 2. And that is the slope of this line here. Now, there are 4 directions for slope. So slope determines the steepness, but then there's also a directional value. So let's take a look at the 4 directions, or 4 types of slope. So a line that, like the one we saw above, that is going upwards as we read the line from left to right, this is called a positive direction or a positive slope. A line that is going downward in direction as you're reading it from left to right, it's going downward. This we call a negative direction or a negative slope. There's also a horizontal line, and we say that this has no slope or zero slope. Okay, so there's no direction here. It's just simply a horizontal line. And then there is a vertical line. And a vertical line has an undefined slope. Undefined slope. And this is because there is a vertical change, but the horizontal change is 0, which means that we're trying to divide something by 0 and we can't. So that is undefined. Let's take a look at a couple more examples here. Here's an example of a negative slope, and you'll notice that when we want to calculate this, we want to find integral components here, integral points. So this point here is where y equals 0 and, y equals -1 and x is equal to 0. So this is a point 0, -1. This point here is where x is equal to -4 and y is 4. So those are the 2 points here. Now we could count the units, or we can use a formula for finding the vertical change and the horizontal change. And the formula for doing that, the slope formula, is y2 minus y1 divided by x2 minus x1, where x2, y2 and x1, y1 are ordered pairs on a graph. So we have those ordered pairs here, and we can plug that into the slope formula. So let's take this as our x2, y2, x1, y1. So our y2 value is 4, and our y1 value is -1. Now our x2, we have to come back up to this value, is -4 minus 0. So here we have 4 minus -1, or 5, and we're dividing that by -4. So this gives us -5/4 slope. The negative here represents the direction, and the 5/4 represents the steepness. I'm just going to write that down here. The negative, this represents direction, and this value here represents how steep the line is. So the steepness of the line. Let's take a look at another example. This is a horizontal line, and we've already said that this has a slope of 0, but let's take a look at y. So in this case, we have a value for y as -1. Now our value for x here is 2, so this is our ordered point 2, -1. And here, this is where x is 3, so this is our point 3, -1. Now you'll notice if we use the slope formula, y2 minus y1 over x2 minus x1. This gives us -1 minus -1 over 3 minus 2. And so we get 0 over 1, which is just 0. So that is a 0 slope. Now take a look at that in contrast to this line here. So this is the point where x equals 0, the line where x equals 0. Here, our value for y is negative 2, and here our value for y is negative 4. So if we were to use the slope formula, y2 minus y1 over x2 minus x1, here our y values are negative 2 minus negative 4, but our x values are 0. And that gives us something divided by 0, which we know can't happen. So we say that that slope is undefined. So just to recap, when you're looking to find the slope of a line, you can do that in two ways. So to find the slope, you can count the units on the grid. So count the rise and run on a graph, and then display or write the slope as rise divided by run. And if you're doing this, don't forget the direction. So this will be positive if it's going upwards, it's a positive slope, and it's negative slope if it's going downwards. And the second way to find the slope is to use the slope formula, and that is y2 minus y1 over x2 minus x1, given that x1, y1, and x2, y2 are ordered pairs. That you're either given or you can find on a graph. And that is slope.